Welcome everyone to the part 6 of this video series on limits that I've been making, and in this video we are going to solve sums based on three formulae, and the three formulae are limit of x tends to 0, a power x minus 1 the whole upon x, and the value for this will be equal to log a. Carefully check the entire result. Limit of x tends to 0, so the variable in our expression has to be x, and that x appears in the denominator. Also it appears as the power of a. What is a? A is simply a constant. It will be a number like 2, 3, 4, 5, 8, 10, 15, 20, anything. So a is a number. The power of it will be x, which is our variable, and that variable appears in the denominator, and that variable, the value of x, has to tend to 0. If x tends to 0, a power x minus 1 the whole upon x, the value for it will be equal to log a. Log a means the base over here is the number e. The second result is limit of x tends to 0, log of 1 plus x the whole divided by x is equals to 1. Again check this thing very carefully. The first term is 1. Of course it is a log term. Inside the log the first term is 1. In the middle you have plus, and ultimately in the end you have x. X was the variable in this question, and that x should tend to 0, and in the denominator you have x. Now the denominator is not the denominator of this, it's the denominator of the entire term. So when limit of x tends to 0, log of 1 plus x the whole divided by x, the value for that will be equal to 1. That's your second result. And the third result can be derived from this very result. See, log of 1 plus x the whole upon x can be written as 1 upon x log of 1 plus x. That 1 upon x goes in inside the logarithm. So it becomes the power of 1 upon x. We had limit of x tends to 0, right? And then we had equal to 1. So if we want to eliminate that log, okay, before that elimination of log, you can take that limit inside the bracket. So limit of log is like log of limit. So we have log of limit of x tends to 0 and the entire thing inside, and that entire thing will be equal to 1. The base here was equal to e. So e power 1 will now be equal to the inner term, and that is why we can say that the inner term will be equal to e power 1, which is equal to e. And that precisely becomes the third result. For all those who have understood the derivation, well and good. If you have not understood, you can simply memorize it just like a formula and try to think a little bit over it. You will realize the logic behind the derivation of that third result. So the third result is limit of x tends to 0. It is 1 plus x power 1 upon x equal to e. Now when to use which particular result? Okay, before that just analyze the third result. The variable is x tending to 0. That variable x which tends to 0 has to come after 1. The first term has to be 1. In the middle you need a plus, and after 1 plus the variable has to appear. So the variable appears in the second position, and the power of the full bracket should be the reciprocal of your variable. So if I have 1 plus, let's say k square, then the power of the bracket should be 1 upon k square, because the variable is k square. The power should be reciprocal of the variable, and limit of k square should be tending to 0. With all these terms being taken care of, the value of this expression will be equal to e, as per result number 3. Okay. Now when to use which formula? That will depend upon what expression you have with you. See, if you have a log expression with you, it is very clear you will use the second formula. If you have a variable as your power, then you will prefer to use this formula. Variable as a power means variable as a power of the entire bracket. If the entire bracket has a variable in the power, then this is the result that you will use. And variable in the power means it should be reciprocal of the variable, and the variable should be tending to 0. With that kind of an expression given, the third result will come into the play. And when will you use the first result? That will be used when you have a power x, that is x as the power of a particular number. Okay, as in when you see the questions, you will be able to decide in a better way which formula to use. So let's begin with the questions. Just check these formulae once, and once you are thorough with all of them, just learn them properly, and once you have just memorized all these results, we can go ahead with the questions. So yeah, take the first question. See, 9 power x minus 5 power x upon 4 power x minus 1. It is very much clear. You have to use the first formula. The expression you have here is nowhere close to the second or the third formula. And that is the reason we are going ahead with using the first formula. How do you use it? See, you need a power x minus 1. You don't have it in the numerator. So you write it as 9 power x minus 1 minus 5 power x plus 1. I have subtracted 1 and added 1 because by doing so I am bringing my entire expression in the standard format. I will write it as 9 power x minus 1, pull out a minus common, and this will become 5 power x minus 1. The whole thing divided by 4 power x minus 1. You can divide the numerator and denominator with x because that is what we wanted in our standard result, right? So we are dividing the numerator and denominator with x. In the numerator you can split the two terms. So it will be 9 power x minus 1 upon x and minus 5 power x minus 1 upon x. You can split the limit. So one limit goes to this, one limit goes to this, and one limit goes in the denominator. So now the numerator is limit of x tends to 0, 9 power x minus 1 upon x. A power x minus 1 upon x was log a. So 9 power x minus 1 upon x, that will be log 9. Minus the second term in a similar way will be log 5. And the denominator is going to be log 4. You can write log of 9 minus log of 5 as log of 9 upon 5. And log of 9 upon 5 divided by log 4. You can write that as log of 9 by 5 to the base 4. And that becomes the final value of the first expression. Solve the second question in a similar way. So you can say this is limit of x tends to 0. 5 power x minus 1. I know we don't have that minus 1, but we will balance it by writing plus 1 in the end. Plus we have 3 power x minus 1. Minus we will pull out. Let's write it as minus 2 power x only for the time being, minus 1. And then in the end we have plus 1 plus 1. That plus 1 and plus 1 is balancing this and this. Where did this minus 1 come from? It was already there in the expression. Okay. So now minus 1 plus 1 plus 1 will give you plus 1. You can pull out a minus sign common from the two terms here. And you can write it as minus 2 power x minus 1. The whole thing divided by x. Split that x and you have x, x and x in the denominator here. After you split the limit, one limit goes with each and every term. And the first term becomes log 5 as per our formula. Second term will be plus log 3. And the last term will be minus log 2. Log 5 plus log 3 is log of 5 into 3, which is equal to log 15. And log 15 minus log 2, that will be log of 15 upon 2. Okay, so that's the value of your second question. And with that we go ahead with the third question, which is very much similar to the questions that we have solved so far. The limit of x tends to 0. Write that minus 3 as minus 1, minus 1, minus 1 and take 1 minus 1 each with a power x, b power x and c power x. So we can rewrite the numerator as a power x minus 1 plus b power x minus 1 plus c power x minus 1. Okay, we need an x in the denominator of every term, but we have a sin x in the denominator. So we can divide the numerator and denominator with x. And when you split the terms in the numerator, you have a power x minus 1 upon x, second term upon x, third term upon x. You can separate the limit also. So one limit goes in the numerator and one limit comes in the denominator. Limit of one term plus limit of second term plus limit of third term. That is an additional step you need to write in your exams. But because it's a very straightforward thing, I am not writing it here. So the numerator will be log a plus log b plus log c as per our formula, and the denominator will be equal to limit of sine theta by theta. Limit of theta tends to 0, sine theta by theta, that will be 1. So denominator is 1 and the numerator becomes log a plus log b plus log c, which is equal to log of abc, and that becomes the final answer for the third question. Moving on with the fourth one, it's an identical one. So we have limit of x tends to 0, 6 power x minus 1. I hope you all realize this minus 1, I have written it extra. So I will balance it by writing a plus 1 in the end. plus 5 power x minus 1 plus 4 power x minus 1 minus 3 power x plus 1. Okay, a power m plus n is basically a power m into a power n. So 3 power x plus 1 can be written as 3 power x into 3 power 1. In the end, keep in mind, we had to write plus 1 plus 1 plus 1, and that will be equal to plus 3. We can pull out a minus 3 common from the two terms here because 3 power 1 will be 3, right? So we are pulling out a minus 3 common from the last two terms. So we have minus 3 into 3 power x minus 1, the whole divided by sin x. And like we had done in the previous question, we are dividing the numerator and denominator with x. Split that x in the numerator. You have x terms here. You can separate the limit also. So one limit goes to the denominator. And each limit, one limit goes to each of the terms in the numerator also. Okay. So once you do that, the first term in the numerator will become log 6 plus the second term log 5 plus the third term log 4 minus the last term which is 3 times log 3, and in the denominator limit of theta tending to 0 sin theta by theta will be 1. So upon 1 is something that we need not write. Log 6 plus log 5 will be log 6 into 5, that is log 30. Log 30 plus log 4, that will be log of 30 into 4, which is log of 120. 3 log 3, that 3 can be taken in the power of 3. So we have log of 3 cube as the second term, that is log of 27. And log 120 minus log of 27, that will be log of 120 upon 27. So that becomes the final value of the fourth question, that is log of 120 upon 27. Moving on with the fifth one. Here we have limit of x tends to 0. In the numerator it is 8 power sin x. We will write it as minus 1 minus 2 power tan x, and we add a 1 here, so it is plus 1 here. But if we take out a minus sign common from there, it will be minus 1 here, divided by e power 2x minus 1. We can divide the numerator and denominator with x. In the numerator also you can split the two terms. So we will have upon x here and upon x here. After splitting the limit, we will have one limit in the numerator, and that limit in the numerator will also go with the two terms. So limit is getting split in the numerator and denominator. In the numerator also let us separate the two limits. So we have limit of x tends to 0, 8 power sin x minus 1 upon x, minus limit of x tends to 0, 2 power tan x minus 1 upon x, and in the denominator we have limit of x tends to 0, e power 2x minus 1 the whole upon x. Now in the denominator here we don't need x, we need sin x. So what we will do is write that x separately over here. Bring a sin x in the denominator, but to balance it you will have to write a sin x here. In a similar way, we don't need x here. So write that x separately over here and bring the term that you require in the denominator. The denominator term that you require is tan x. We write a tan x there, but we will balance it by writing a tan x here also. In the denominator here, you need a 2 here. So we balance it by writing a 2 here, because there was a 2x here, we needed 2x here. Okay, that's how we have rearranged all our terms. We can split the limit here as well as here. So if you realize the first term here, this becomes equal to log 8. Limit of x tends to 0 sin x upon x will be equal to 1. So let me just rub out this part, and I will evaluate that expression which we have just written in the space that we have just created here. So this will be log 8 into 1, that's log 8 is this expression, into 1 is this, minus this will be equal to log 2. This will be equal to 1, so it's log 2 into 1 divided by 2 outside the limit, so we have 2 into, this will be equal to log e. But log e is equal to 1, so in the denominator we have 2 into 1, which is simply equal to 2. In the numerator it is log 8 minus log 2, and log 8 minus log 2 is like log of 8 upon 2, but log of 8 upon 2 is log of 4. 4 can be written as 2 square, and that 2 power 2, this 2, the 2 in the power can be taken out and can be written as 2 log 2. So we have 2 log 2 divided by 2, 2 gets cancelled, and log 2 is the final value of this given expression. So the final answer here for the fifth question is going to be equal to log 2. Moving on with the first main question in the first question in the second main question. So what you can do here is, you can write it as limit of x tends to 0. See, you have a 3 power minus x in the numerator, which can be written as 1 upon 3 power x minus 2 divided by x tan x. If you combine the terms in the numerator by taking an LCM, the first term will be 3 power x into 3 power x plus 1 minus 2 into 3 power x, the whole divided by 3 power x. Now 3 power x into 3 power x, k into k is k square. So 3 power x into 3 power x will be the square of 3 power x. We have, think of 3 power x as k, okay. We have k square minus 2k plus 1, and that forms the expansion of k minus 1 the whole square. So the numerator is k minus 1 the whole square. That is 3 power x minus 1 the whole square. Take that 3 power x in the denominator only, and let's write that entire expression in only 2 lines. So in the numerator we have 3 power x minus 1 the whole square. The denominator contains 3 power x and x tan x. Now see, we need an x in the denominator of this term, but we have that term as basically square. So we have this term 2 times, and that is why we need an x 2 times in the numerator. So we will divide the numerator and denominator with not x but the square of x. So if we divide the numerator and denominator with x square, we have limit of x tends to 0, 3 power x minus 1 the whole square upon x square divided by 3 power x into x tan x the whole upon x square. In the denominator you can cancel one x and x. So you get tan x upon x in the denominator, and here also if it is a square upon b square, you can write it as a upon b the whole square. So you can take that x inside the bracket and write it as 3 power x minus 1 upon x the whole square. Split the limit. So one limit goes to the numerator, one limit comes to the denominator. You can write one limit along with 3 power x. So we have limit of x tends to 0, 3 power x, into we have a second limit here, that is limit of x tends to 0, tan x upon x. And in the numerator also take this limit inside. So we can write it as limit of x tends to 0, 3 power x minus 1 upon x the whole square. Now the numerator becomes log 3 the whole square. The denominator becomes 3 power 0, which is equal to 1. So 1 into limit of x tends to 0, tan x upon x will be equal to 1. So the denominator is 1 into 1, which is 1, and the numerator is log of 3 the whole square, and that becomes the final value for the first question. Okay, so the final value for this question is log 3 the whole square. With that we move on with the second one. Now if you check the second question properly, see, you have a 1 upon x in the power. So you need to realize that so far we have been using only and only our first result. All the sums so far were based only on this result. Now that we have 1 upon x in the power, it is very clear that we have to use our third result. So let's go ahead with applying that result. See, to apply the third result, you need the first term as 1. So from the two brackets inside, from the numerator and denominator in the bracket inside, you need to pull out a 3 common. So you can say 3 into 1 plus x upon 3 divided by 3 into 1 minus x upon 3. By doing so, you are ensuring that the first term is equal to 1. You can cancel over 3 here and here. So let's just not write it because it is getting cancelled. And now you can split the power also. So write 1 upon x as the power here and 1 upon x as the power here, and split the limit also. So one limit goes to the numerator, one limit comes to the denominator, and that finally is the value of this expression. To simplify that further, you can say you have in the numerator limit of x tends to 0, 1 plus x upon 3 the whole power 1 upon x. Now see, the problem is here you have x upon 3. So the power should be 3 upon x, but it is 1 upon x. We will write it as 3 upon x, but into we will say it is 1 upon 3. Now a power m into n is like a power m the whole power n. So we can say that this entire bracket is like a power m, the whole power n, that is, we can write 1 by 3 as the power of the entire bracket. You can take this limit inside the bracket and then you will have 1 plus x upon 3, the whole power 3 upon x, that with the limit and power 1 upon 3. In a similar way, try to rearrange the denominator. So the denominator will be limit of x tends to 0. See, it is 1 minus x upon 3, right? So the power should be not not 3 upon x, but minus of 3 upon x, because if you realize the result was 1 plus x power 1 upon x. Whatever comes after plus is your variable. So you can think of this minus x upon 3 as plus minus x upon 3. So after the plus, what you have is minus x upon 3. And that is why in the power you should have a minus 3 upon x. But the power was 1 upon x. So to balance that minus 3, I need to multiply that power with minus 1 upon 3, and multiplying with a power means taking that number as the power of the entire bracket, like we had done over here. Go through the steps once that I have discussed over here, because you need to see those steps maybe twice or thrice to get a knack of it, to understand it thoroughly, and only after you have understood the steps thoroughly, go ahead with the further questions. Okay, so in the numerator, this entire term is in the format of our standard result, that becomes e, the power of which will be 1 upon 3. In the denominator, this is also in the format of our standard result, so we have e power minus 1 upon 3. This is a power m upon a power n, that is a power m minus n, so that is e power 1 by 3 plus 1 by 3, that is e power 2 by 3. And e power 2 by 3 is the final value of the second question. Let's go ahead with the third one, which is exactly the same question. A similar question. There's nothing new that you have to do in this question. So x tends to 0. The variable is 5x and the variable is 2x. But the first term has to be made equal to 1, which is why we will pull out a 3 common from the first two terms. From the numerator and denominator, we will pull out a 3 common. So 3 into 5x by 3 plus 1. And we will prefer to write it as 1 plus 5x upon 3. The whole divided by 3 into 1 minus 2x upon 3. The power of the entire bracket is 2 upon x. 3 gets cancelled. Separate the powers. So 2 upon x is the power of the terms in the numerator as well as denominator. Limit x tends to 0 goes to the numerator as well as denominator. If you simplify that further, you have, in the numerator you can write limit of x tends to 0. See, it is 1 plus 5x upon 3. So we need the power as the reciprocal of this, that is, we need it as 3 upon 5x. But what was the power? It was 2 upon x. So eliminate that 3 upon 5. Eliminate first that 3 upon 5 by taking the power as 5 upon 3. But you need to bring a 2 also. So you will multiply with 2. That is how we are balancing the numerator. The denominator will be limit of x tends to 0. 1 minus 2x upon 3. The whole power. Now the power should be minus 3 upon 2x. So eliminate that minus 3 upon 2 by multiplying with minus 2 upon 3. And you need an extra 2 there. So we multiply this with 2. So that is how we have balanced the entire expression. The inner terms in the bracket become equal to e because they are in the format of our standard result. So in the numerator it is e power 10 upon 3. In the denominator it is e power minus 4 upon 3. So e power 10 upon 3 upon e power minus 4 upon 3. That will be e power 10 upon 3 minus of minus 4 upon 3. That is 10 upon 3 plus 4 upon 3. That will be equal to 14 upon 3. And yeah, e power 14 upon 3 becomes the final value of the third question. Yes. So with that, let's go ahead with the fourth question. So we have limit of x tends to 0. And now that we have a log term, it is very clear that we have to use our second result. Second result is the one that we have discussed here. It's this result that we need to use. So limit of x tends to 0 log of 1 plus x upon x. So again, in this question, it is very clear that we need to bring 1 as the starting term, and to bring 1 as the starting term, we have to take a 3 common from the two brackets. So we can write the first bracket as log of 3 into 1 minus x upon 3 minus log of 3 into 1 plus x upon 3, the whole divided by x. Log of a into b is like log a plus log b. So the first term becomes log 3 plus log of 1 minus x upon 3. Similarly, let's keep this entire thing in one bracket. Okay, so even this term is like log of a into b, which can be written as log a plus log b. So this will be log 3 plus log of 1 plus x upon 3. If you open up the bracket here, this term will be minus log 3 and this term will be minus log of 1 plus x upon 3. Now log 3 minus log 3 gets cancelled. So if you eliminate that log 3, you are finally left with log of 1 minus x upon 3 minus log of 1 plus x upon 3, and with that we split the denominator also. So we have an x as the denominator of both the terms. Now if you compare it with log of 1 plus x upon x, then in the denominator here you need minus x upon 3. So I am writing a minus 1 upon 3 here. To balance it, I have to write a minus 3 here. That minus 3, let's write the limit here first. So we have limit of x tends to 0. The minus 3 that we had written here can be written as minus 1 upon 3 right here. The limit was also going to split, and that is why the second term will also have a limit along with it. So we will have our second term as limit of x tends to 0. Log of 1 plus x upon 3, the whole divided by x. Write an upon 3 here, multiply it with a 3 here. That 3 which you have written here can be written outside over here. So now the final value is minus 1 upon 3. This expansion or this bracket or that first expression which you see here is in the form of limit x tends to 0, log of 1 plus x divided by x. And that is why the value for this entire expression will be 1. So we have minus 1 upon 3 into 1. Minus 1 upon 3 into this bracket similarly, that is log of 1 plus x divided by x. The value for this bracket also as per our result will be equal to 1. So we have minus 1 upon 3 minus 1 upon 3. That is minus 2 upon 3 as the final value for the fourth question. Moving on with the fifth one. We have this as limit of x tends to 0. Split the power. So we have the first numerator. We have the numerator as 4x plus 1, which is like 1 plus 4x only divided by 1 upon x. In the denominator you have 1 minus 4x power 1 upon x. Split the limit. If you have a 4x here, the power should be 1 upon 4x. So let's write it as 1 upon 4x. We can balance that 4 by multiplying this thing with a 4, and that 4 becomes the power of the entire term, because a power m the whole power n was a power m into n. We got a power m into n, which we will write as a power m the whole power n, and we will take limit inside the bracket. So we have this entire expression here. Similarly, we will write the power here as minus 1 upon 4x. To balance the minus 4 that we have introduced, we will multiply it with minus 4. So that minus 4 becomes the power of the entire bracket here. And finally, we have the value of the full expression as e power 4 divided by e power minus 4. This will be e power 4 minus minus 4, that is e power 4 plus 4, which is equal to e power 8, and that's the value for the fifth question. Sixth one, exactly identical. Limit of x tends to 0. Pull out a 5 common from the two terms. So you have 5. 1 plus 7x upon 5 divided by 5. 1 minus 3x upon 5. The whole power 1 upon x. 5 gets cancelled here and here. And you can now separate the two powers also. So you have 1 upon x as the power here. 1 upon x as the power here. Split the limit. So we have limit of x tends to 0 here. And we have limit of x tends to 0. Keep in mind, all we have is 1 upon x, but we wanted 5 upon 7x. So we are writing 5 upon 7x here. and to balance the 5 upon 7 that we have introduced, we will write 7 by 5 here. Similarly, in the denominator, the power will be written as not 1 by x, but as minus of 5 upon 3x, basically the reciprocal of this. So to balance that minus 5 upon 3 that we have introduced, we will write the power as minus 3 by 5. So now the inner term becomes equal to e. We have e power 7 upon 5 divided by this becomes equal to e. So we have e power minus 3 upon 5. E power 7 by 5 upon minus 3 by 5, that will be e power 7 by 5 minus of minus 3 by 5, that is e power 7 by 5 plus 3 by 5, that will be e power 10 by 5, but that will be equal to e power 2. So e square is the value of the sixth question. Let's go ahead with the third main question. And to bring everything in the standard format, we have limit of x tends to 0. A power x minus 1 minus b power x plus 1. Pull out a minus common from the last two terms and you have minus of b power x minus 1, and we will keep the first two terms also in a bracket. Divided by, we have sine 4x minus sine 2x. Divide the numerator and denominator with x. Separate that x in the numerator as well as denominator. You can split the limit also. So we will have a limit in the denominator and a limit in the numerator. The limit in numerator will also split in two parts. Limit of first term minus limit of the second term. I am not writing it separately. In the denominator we will write it separately. So we have limit of first term minus limit of the second term. Okay, we are bringing a 4 here, and to balance that 4 we are writing a 4 here. We are bringing a 2 here, and to balance that 2 we are writing a 2 here. Evaluate it straight away. So now in the numerator you have log a minus log b. Divided by 4 into 1 minus 2 into 1. So in the denominator we have 4 minus 2, which is equal to 2. Log a minus log b will be equal to log of a upon b. So we have half log of a upon b as the value for the first question. Go ahead with the second one. See, it's very clear we need an x in the denominator of this, but the power is 3. So we need to divide the numerator and denominator with x cube. How you will simplify it in the denominator, that we will check later. But divide the numerator and denominator with x cube first. So you will have 2 power x minus 1 upon x the whole cube. And you can take that limit inside the bracket. So this is your numerator. In the denominator we have limit of x tends to 0. Keep in mind you have divided the denominator also with x cube. So you have 3 x terms in the denominator. We will write one of those x terms in the denominator here into, after splitting the limit, the second term will be sin x. We need an x in the denominator here also. So we were left with 2 x terms, one of which we have written here. So we have used up 1x here and 1x here. We are left with one more term in x, and that we will write in the denominator of the last term. So we have limit of x tends to 0. The last term will be log of 1 plus x, the whole divided by x. Evaluate the final expression. So this will be the numerator being log 2 the whole cube. The denominator is this term, that is log 3, into this term which is equal to 1, into this term which is also equal to 1. So into 1, the final value for this expression is log of 2 the whole cube divided by log 3. That's how simple the questions are. Go ahead with the third one. All you need to do is factorize the numerator. Keep in mind 15 power x can be treated as 5 into 3 the whole power x, which is actually equal to 5 power x into 3 power x. Then we have minus 5 power x minus 3 power x plus 1. Pull out 5 power x common from here. So after doing that we have 5 power x into 3 power x minus 1. Pull out a minus 1 common from here. So we have minus of 3 power x minus 1. Treat this term as k and k. So we have 5 power x into k minus k. You can pull out that k common from the two terms here. So that will leave you with k, which is 3 power x minus 1. Into the second bracket we'll have 5 power x minus 1. So this becomes limit of x tends to 0. The numerator being 3 power x minus 1 into 5 power x minus 1. And the denominator is x into sin x. We need an x in the denominator here and we need an x in the denominator here. So we are dividing the numerator with x square, and that is why we will divide the denominator also with x square. You can separate the limit, so one limit is there in the numerator and one in the denominator. X and x square get cancelled, leaving you with sin x upon x in the denominator. So the final value here will be the first term being equal to log 3 into the second term being equal to log 5 divided by the denominator being equal to 1. So the final value for this expression is log 3 into log 5, and that's how we are solving the third question. Move on with the fourth one. We have limit of x tends to 0. 25 power x. See, 25 is like 5 power 2. So 25 power x is like 5 power 2 the whole power x. This will be 5 power 2x. Think of it as 5 power x into 2, and we can write it as 5 power x the whole power 2. So 25 power x is basically 5 power x the whole square. So the numerator is 5 power x the whole square minus 2 into 5 power x plus 1. K square minus 2k plus 1, that becomes k minus 1 the whole square. So the numerator is 5 power x minus 1 the whole square, and the denominator is x into sin x. We need an x in the denominator here, but because this is a square, we will have to divide it with x square. So we are dividing the denominator also with x square. Separate the limit. X and x gets cancelled here and here. The denominator will be sin x upon x. A square upon b square. Write it as a upon b the whole square. So we have 5 power x minus 1 upon x the whole square. Take that limit inside the bracket. So you have limit of this and square of this entire bracket. So in the numerator you have log 5, the square of it divided by the denominator is 1, and that becomes the value of the fourth question. Take one last question in this video. So 49 power x, just like in the previous question, 25 power x was 5 power x the whole square. Here this becomes 7 power x the whole square minus 2 into 35 power x. Think of it as 5 into 7 the whole power x. That is 5 power x into 7 power x plus this becomes 5 power x the whole square. A square minus 2ab plus b square, that is the expansion of a minus b the whole square, and that is why in the numerator we can say we have 7 power x minus 5 power x the whole square. In the denominator we have sin x into log of 1 plus 2x. Divide the numerator and denominator with x square. So when you take that x in the denominator here, it was x square, right? You are taking it inside the bracket. So it is 7 power x minus 5 power x upon x the whole square. In the denominator, the x square will be split as x and x. 1x we will write it under the sin term, and 1x we will write it with the log term. Split the limit. So one limit goes in the denominator also, and we will write the two terms separately. That is limit of x tends to 0, sin x upon x into limit of x tends to 0 and the second term. This is your first term, and the second term will be written as this entire thing. We have a 2x here, right? So we will bring a 2 here and we will balance it by writing a 2 here. So let's take that 2 outside the bracket only. So this is one term, this is one term, into 2 is what we have, and in the numerator we need to go for a further simplification. Take that limit inside the bracket, so we have the square of this. We can write 7 power x minus 5 power x as 7 power x minus 1 minus 5 power x minus 1. Split that term in x. So you have an x term here and an x term here. You can split the two limits. One goes with this, one limit goes with this. So finally the value for the full thing will become equal to this. The numerator will be log 7 minus log 5 the whole square. In the denominator it is this term, which is equal to 1 by formula. This term, limit of log of 1 plus x divided by x will be equal to 1 into, we have a 2 here. So the denominator is 2. So we have half outside the bracket. Log 7 minus log 5 will be log of 7 upon 5. But we have the square of it. So we say log of 7 by 5, the whole square. and that is the value for the fifth question. This is where I am done with discussing whatever I wanted to discuss in this video. I hope whatever contents I have covered have been somewhere helpful to you in your preparations. Thank you for watching, and do check out the other videos of this playlist.